And then we are going to start today's class by praying together. Okay, before we start the class, let's pray together. Okay. Before I explain to all of you how to draw a three-dimensional object by using WebGL, I would like to prepare my Visual Studio Code first, and all of you can. Okay. I apologize before because in my home, in my city, in Sumeneb, today, there is some electrical problems maybe. So I cannot turn on the electricity here. Yeah, because there is some problems. So I don't know. I can record this meeting. Wait a minute. Yeah, maybe Imam can help me to record. Yeah, Imam.
Yeah, unfortunately, I also forgot to install OBS. I just reinstalled Windows. Is there anyone in the class willing to help us in recording today's meeting?
Maybe Nabil can help us.
I would like to ask Mr. Hazik to help me to record this meeting because Mr. Hazik cannot wait a minute, cannot join our class today. Cannot join today class because he has a meeting with DPTSE. So I don't know. Yeah, but
Yeah.
he said yeah.
Someone said Nabil maybe can help us. Nabil, are you willing to record today meeting? Is that okay?
Okay, Nabil.
Or is anyone comfortable using OBS to record today's meeting?
I will do a recording as well.
Okay. Oh, Mr. Hazik. Okay, thank you very much.
Yeah, thank you very much
for your coming today. Okay, thank God because I don't know what to do because yeah, I cannot running the OBS in this laptop because I don't know it will have a high battery consume. It will consume high energy, high power. So I cannot charge my laptop. So I cannot use the OBS. Okay. Okay, guys, we are going to start. First, we need to prepare the Visual Studio Code. Yeah, you can open your Visual Studio Code. We are going to continue our previous code from the GitHub. I had download the source code. Now we are going to continue with going to share screen. Okay. This is the source code that I had downloaded from the GitHub. This is the last version from class E. We are going to edit and continue this code to try to draw a three-dimensional object by using the WebGL. Okay, I don't know. Should I use the live share to make you to show this source code to all of you? But it will I'm afraid it will consume more energy more power of my laptop, so yeah, I think I'm not going to i'm not I'm not going to live share my my workspace to all of you, so you can show from your monitor, and I will push to the GitHub the last version of the source code after we finish this course. Okay. From the previous source code, we learn to move the rectangle. If you remember, we try to draw a triangle by using GL triangles. Here, draw a erase GL triangles. In this source code, we are going to draw a rectangle by using GL triangles. We need 6 points to draw a rectangle by using GL triangles. Here we define the point in this vertex variable. Yeah. If we use GL triangles to draw a triangles, we need 3 points. And to draw a rectangle here, there are 2 triangles to create there are 2 there are 3 2 sorry there are 2 triangle to create a rectangle. We need 2 rectangle to create 1 rectangle. Kita butuh 2 segitiga untuk menggambar segi 4. So here we define 6 point of triangle to create our rectangle. Jadi di sini kita mendefinisikan 6 buah titik untuk triangle tadi, segitiga tadi, untuk membuat rectangle. Seperti itu. Wait a minute. Okay. This is the vertex, and then this is the GL buffer, yeah. This is a linked list. I think all of you have learned about that. This is the Vertex Shader code, Fragment Shader code, and then this is the function that we are create in the 3 weeks ago. And in the function, there is something missing. If you remember, we do not implement the border. So if we run this code, the rectangle that we create by using GL triangles will be missing if the position is lewat dari segi 4-nya gitu ya. Wait a minute, I'm going to run. This one. This source code use input keyboard space and use mouse click. This source code use key. Sorry, wait a minute. Bentar. Suara saya menggema. Wait a minute. I don't know. So,
I'm sorry, Miss.
yeah.
But I think why your voice is echoing because I think Mr. Hazik is still have his microphone on.
Oh yeah.
No, I'm sorry.
Maybe.
I'm sorry.
Okay.
Thanks for reminding me.
Okay. Thank you very
no
much,
problem.
Mr. Hazik. Okay, I apologize to all of you guys because I cannot hear anything clearly when my voice is echoing. Okay, I'm going to explain again. This is the source code that we made in the 3 weeks ago. From the 3 weeks ago, here we try to create a rectangle by using 2 triangles. Yeah, we are going to create a rectangle by using 2 triangle. The 2 triangle is created by using this GL triangles. By using this GL triangles function, we need to define 6 points. Yeah. By using the GL triangles, we need to define 6 points to draw the rectangle. Yeah. So this is the vertex variable. The vertex variable here is used to define the position of each point that we use here to draw a triangle, two triangles to create a rectangle. This is 2-dimensional object because we only use the X and Y position. This is the two parameter here is the position for X and Y, and the last three parameter is the color. We define the color in this vertex variable. And then here we use vector 2 dimension. There is a attribute variable. By using the attribute variable name a position, the attribute variable here that is named a position is a vector that has 2 dimension because it stores the position of X and Y of the object that we are going to draw in the canvas. This only have the X and Y position. It's different from the vector 3 color because this color has three parameters, red, green, and blue. So this attribute variable has vec3 to store three variables, three numbers, red, green, and blue in this a color variable. In today's lesson, we are going to draw a 3 dimension. In 3 dimension, we not only use X and Y, but also Z. Yeah. So here we are going to change and add some position for Z coordinate. When we try to use GL triangles, when we are trying to draw by using GL triangles, we need to define 3 points that will be that will be used to draw the triangles. Ya, jadi kalau pakai GL triangles kita butuh 3 titik ya. GL triangles untuk menggambar segitiga kita butuh 3 titik. To draw a triangles we need 3 points by using GL triangles. So if we are going to draw a rectangle, jadi kalau kita ingin menggambar segi 4, we need 6 points. In a 3-dimensional object, for the example we are going to draw a cube. Jadi misalnya contohnya dalam objek 3 dimensi kita ingin menggambar cube atau kubus. We need 6 ya. Sisi kubus kan ada 6 ya. There are 6 ya. We need 6 rectangle. Ya, we need 6 rectangle. Jadi sisi kanan kiri, atas bawah, depan belakang ada 6. Kita butuh 6 segi 4. So, by using these GL triangles, we need to define 6 dikali, kalau ini kan 1 ya, 1 segi 4 kita butuh 6. Berarti kalau kita butuh 6 sisi, kita butuh 6 kali 6, yaitu ada 36 titik yang harus kita definisikan untuk membuat sebuah kubus. So we need to define 36 points to create a cube by using this web GL and GL triangles function. Ya, oke. Oke, sampai di sini ada yang dibingungkan? In this vertex variable, we only define 6 points. And then we are going to change this and define the total, we are going to define total 36 points that will be used to draw a cube. Oke. Kita akan mendefinisikan posisinya. Sebentar. For the example, we are going to draw a cube. This is only one point, ABC. Yeah. I'm going to change. This is the position of X and Y, and then we are going to add Z, and we are going to set the Z as 0, maybe in the Z coordinate, or maybe we are going to change all the vertex location, maybe to, wait a minute, to we are going to -1 maybe, -1 and -1. This is the first point, and then 1, -1, and 1. Sorry, and -1. We are going to try to draw in the sketch, in the paper after this, in the ya di sini nggak ada whiteboard ya, it's okay. Di PPT aja. I'm going to draw the position of the vertex, the point, and then one. This is the second. This is the first point, second point, and this is the third point. The third point, 1, 1, and -1. And the fourth point, 1, -1, 1, and -1. Something like this. This is the first. Okay, wait a minute. I apologize because so many children in my village. So all of you can hear. They are playing around my house. Okay, -1, -1, and -1, and then 1, -1, -1, 1, 1, -1, -1, 1, and -1. Okay, this is, and then we has defined 4 points here. This is the position of 4 points, first 4 points, and then next we are going to find another points. For the example, I searched in the Google for this tutorial, and then right now I'm going to explain what I have learned, so you can understand what I have found in the internet to draw a 3-dimensional object by using the WebGL. This is the next position. Okay, and the next is we have 8 points here right now, and then this is the next -1, -1, -1, 1, 1, -1, -1, 1. Okay, I'm going to check it first. Okay, this is -1 and -1. Then -1 is 1. Okay. The next is this one is used to define triangles. Wait a minute. Yeah, in this program we are going to use the GL triangles. These points will define a CCA, yeah, rectangle A for one of sisinya dari ini, the side of the cube. We are going to define the points of the side of the cube. This is the CCB. Then CCJ. And then ini, the next is CCD. Satu, -1, -1, 1, 1, -1, 1, 1, 1, 1, -1, 1. Okay, wait a minute. I'm going to check it first. because there are so many points that we define here. I'm afraid we will miss something, so our cube cannot be cube. Jadi kubusnya tidak akan jadi kubus. Satu. Ini. Okay, then min 1, 1, min 1, min 1, min 1. Okay. This is the CCD and E, and then last min 1, min 1, min 1, 1, 1, 1, min 1. Okay. And then min 1, 1, min 1. Then min 1, 1, 1. Then 1, 1, 1. 1, 1, min 1. Okay, this is the vertex that we have defined to create a cube. Yeah, to draw a rectangle by using GL triangles, we need 6 points. But here, we can draw each side of the cube by using this defined vertex. There are total 12 vertex for each side of the cube. So we have total here, this is 12. 12, we can, wait a minute. We can multiply this 12 with 6 side of the cube. A, F. Yeah, this is the point of each vertex that define a rectangle of each side of the cube. This vertex is used, ya, titik-titik ini digunakan untuk mendefinisikan rectangle segi 4 yang menyusun sisi-sisi kubus, seperti itu. These points, this vertex is used to define a rectangle for each side of the cube. Okay, this is the vertex. And then in this variable, we only draw a vertex. Yeah, in this variable, we only define a vertex. For the next, we need to define the color of each vertex. Ya, jadi di sini kita baru mendefinisikan titik-titiknya nih, teman-teman. Selanjutnya, warnanya seperti apa? Ya, we can use the same variables here. Kita bisa menggunakan variabel yang sama di sini, but I'm afraid it will make you confused because there will be a lot of variable, there will be a lot of numbers here. Ya, jadi kalau misalnya kita jadikan satu variabel color dan vertex dalam satu variabel ini, itu takutnya akan membingungkan teman-teman karena akan ada banyak angka di sini. Ya, if we define the color and the position of the cube in the same variable, in this vertex variable, I am afraid all of you will be confused because there are so many numbers defined here. So I am going to divide between the vertex position and the color. So here in the 23rd line, I'm going to define a new variable called colors. Here. This variable colors, there are total 4 points here in one line ya. Di masing-masing line ini, masing-masing baris punya 4 poin. Ada 4 titik yang didefinisikan di masing-masing poin. There are 4 points defined in each line in this vertex variable. So here we need to define total 4 multiplied by 6, yeah. There are 6 sides of the cube. 4 multiplied by 6. So there are 24 color definition. Red, green, blue. 24 we are going to multiply by 3. The total is 72 if I'm not wrong. Ya, jadi kalau kita lihat di sini tuh ada 4 titik ya. Titik pertama, titik kedua, titik ketiga, dan titik keempat. Ya kan kita pakai 3 dimensi ya, X, Y, Z seperti itu. Jadi ada 4 titik yang didefinisikan di masing-masing baris di variabel vertex. Jadi untuk warnanya, untuk masing-masing sisi kita juga harus mendefinisikan 4 warna untuk masing-masing sisinya, ya kan, untuk masing-masing titik di sisi itu. Ya, jadi ada satu sisi berbentuk segi 4, ada 4 titik di mana masing-masing titik ini harus kita definisikan warnanya. Dan warnanya itu sendiri dia punya 3 parameter, red, green, dan blue. Jadi 4 dikalikan 6, 24. Lalu 24 dikalikan 3 untuk masing-masing parameter warna red, green, dan blue. Jadi totalnya adalah 72 atau 72. Gitu ya. Okay, this is the colors. For the first, I'm going to add red, green, blue. We are going to add blue. And then the second, we are going to add blue. Ya, sorry. Jadi di sisi pertama saya akan menggambar warna biru semuanya. All of the point in the A side, in the first side of the cube, I'm going to draw by using blue color. I'm going to draw a blue color in the A side, in the first side of the cube, ya. And then 0, 1. Kalau ini kan biru ya, 001. Ini kurang koma. Yeah, there are four color define 4 color definition for each point in a rectangle. Ya, jadi ini ada 4 titik di mana masing-masing titik punya 4 definisi warna. This is for A, and then the B, I'm going to make it yellow maybe. Yeah. I search from the internet for the yellow color. We can use red, green. This one. It will return the the yellow color. Itu merah karena belum koma. Okay. I'm going to do this copy paste. So yeah. Okay. Sorry. This is for B, and then C. I'm going to copy paste again. For the next side of the cube, I'm going to draw by using the green color, maybe. Red, green. Okay, green, red, green, blue. Okay, and then for D, I'm going to draw red, yeah, by using the red color. Okay. Sisi D. For E, I'm going to use Tosca, maybe. Yeah, we're going to use Tosca. The Tosca color is 0. You can use GIMP or any photo editor to search this combination of color. Yeah, or maybe you can find any other way to find the color combination by using this RGB, red, green, blue. For me, I use GIMP for photo editor, or maybe you can use Photoshop. there is a color palette, so you can choose the color there, and then you can see there the color combination of red, green, blue to form the color. Jadi kalau kita pakai GIMP atau Photoshop, di situ ada color palette. Ketika kita klik salah satu warna di situ ada definisi dari RGB-nya, ya, the RGB definition. So you can see there, Anda bisa melihat di situ color kombinasi warna dari masing-masing red, green, blue untuk membentuk warna tersebut, semacam itu. Ini A, B, D, E, this is F. Okay. So we have blue, yellow, and then green, red, Tosca. This is Tosca. Oh, yellow. This is yellow again. Oh, no, this is Tosca and then yellow again. Okay. Okay, then the next. Because here we use vertex and colors here. So we need to define the buffer, not only for the vertex, but also for the color. Besides, we define the vertex and the color. Here we also will define a line in this. Yeah, I don't know what's that. Wait a minute. We need to define a index. What? How to pronounce? We need to kita butuh mendefinisikan semacam indeks dari masing-masing titik-titiknya itu tadi. We are going to define by using the array var in this, something like that. This index will be used to identify the vertex. This numerical values. We call it index. The index used to draw a mesh in WebGL. We're going to draw a mesh by using this index variable. This identify the vertex. This index variable is used to identify the vertex, and this also will be used to draw a mesh by using the WebGL. So we need to define the index of our cube. Nol, satu, dua, nol. Komanya belum. 0, 2, 3. Lalu ada 4, 5, 6. 4, 6, 7. Lalu ada 8, 9, 10. 8, 10, 11. Lalu ada 12, 13, 14, 12, 14, 15. This is they have a pattern, mereka punya polanya sendiri untuk gambar indeks ini tadi. Total indeks yang akan kita buat di sini adalah 12. Variabel indeks ini digunakan untuk mengidentifikasi vertex, untuk mengidentifikasi vertex. Sisi 6 kubus punya 6 sisi. Masing-masing sisi itu punya poin atau titik-titik. Nah, karena kita menggambar dengan menggunakan GL triangles, we need to define 4 different points here. GL triangles. Ada 4 titik kurang lebih di sini yang kita definisikan untuk menggambar satu rectangle, to draw a rectangle by using GL points. Not GL points. To draw a rectangle by using GL triangles, here GL triangles function, we need to define total 4 point in this case. In this case this is for A, for B, C, and D. Jadi ini untuk sisi A, B, C, D, dan E, F. Jadi di kubus kan ada 6 sisi, ada 1, 2, 3, 4, ada 8 ya, ada 8 titik, kok 8? Ada 4 titik, untuk rusuknya ada 12 ya. Nah, jadi ini untuk mendefinisikan sisi-sisinya. Lalu kalau ini untuk mendefinisikan warna di masing-masing sisi. Sedangkan indeks ini kalau kita cari di internet, di dalam WebGL, we need to identify the vertex. Kita butuh untuk mengidentifikasi vertex yang kita buat di variabel vertex sebelumnya. Nah, kita perlu untuk mendefinisikan beberapa angka. We need to define a numbers. Ya, these numbers are known as index. Jadi angka-angka ini kita kenal dengan namanya index. Lalu index ini are used to draw a mesh in WebGL. Jadi variabel index ini digunakan untuk menggambar mesh dengan menggunakan WebGL dari kubus yang akan kita buat nanti. Jadi, just like vertex, we store the index using JavaScript array and pass them to WebGL rendering pipeline using index buffer. Jadi sama halnya dengan vertex ini ya, variable vertex dan juga colors. We need to define this index in the array variable and then we are going to pass this variable by using the buffer, by using the array buffer. I hope you understand what I explained. Okay, we are going to continue to define the index 17, 18, 18, 16, 18, 19, lalu ada 20, 21, 22, 20, 23. Okay. This is the index variable. Ini totalnya indeksnya ada 12 ya. 12, kalau kita ingat 12 untuk menggambar mesh di sini sepertinya dia menggunakan rusuk dari kubusnya tadi. Kalau kita lihat kubus ada 12 rusuk ya. 1, 2, 3, 4 untuk yang di atas, yang di bawah juga ada 4, jadi ada 8. Yang ada di sisi-sisi yang mengelilinginya juga ada 4, jadi ada 12 totalnya. Seperti itu. Selanjutnya, we are going to create the buffer variable as a linked list ya. We need to define the buffer variable to create a linked list for storing the vertex, the index, and also the colors data. Ya, ini untuk vertex data. We are going to copy and paste here. Yeah. Wait a minute. Okay. I forget this. Okay, this is for vertex. This is for color. And the last is for index. Okay. This is for vertex. New float 30. This float 32 array is at the default data type that will be used in this buffer to store the vertex data. Astagfirullah, saya kaget. Itu siapa? Okay, it's okay. Okay, the next here, after the vertex, after we define the variable buffer for vertex, yeah, we are going to rename it as vertex buffer. Yeah, vertex buffer. And then this one, I'm going to copy here, vertex buffer, GL static draw. This is, this is the default folder. This is the, our object. Ya, objek yang kita buat jadi segitiga karena kita definisi tadi ya. Oke, vertex buffer, and then buffer GL data for 32 array GL static draw. And then for the color buffer, we are going to create a new variable called color buffer. Color buffer, GL create buffer, GL bind buffer. I'm going to rename this as a color buffer. And this one, not vertex, but colors. Okay. This is the colors. And then the last buffer variable is index. Index buffer. This index buffer, And then we're going to change this, not the vertex, this in this, this one. Okay, for the index variable, we are not going to use the float 32 array because here the index variable is a numerical value. The value is not float but integer. Yeah. So we are going to use integer value, integer array of integer. Wait a minute. The array of integer is u in 16 array, something like this. Okay, L static draw. Index, yeah. This is for the mesh. To draw a mesh by using the index, we need a array of integer. So the data type in this parameter, where we change to integer 16 array element. And then here, there's also different here. Index buffer, GL create buffer, GL bind buffer. We are not going to use the array buffer, but we are going to use GL element array buffer. This one. GL element array buffer. In this buffer, we use array of integer to store in this variable to draw the mesh in our 3D object, three-dimensional object. Okay. Okay, we are going to continue after we create a linked list to store the vertex, color, and index data. Now we are going to continue to define the shaders like the usual. We need to define the vertex shader, the fragment shader to draw our object in the canvas. Okay, wait a minute. I'm going to find the shaders. Okay. First, we are going to define the vertex shader code here. Vertex shader code. The vertex shader code, vertex shader source, The vertex shader source is attribute vec to a position. In this case, for the previous week, we tried to create a two-dimensional object. So we only need X and Y position. But today we are going to draw a three-dimensional object. So we need three position, X, Y, and Z. So we are going to change this two-dimensional vector to three-dimensional vector. Yeah, vec 3. Because we are going to draw a three-dimensional object. So there we need to define three position for X coordinate, Y coordinate, and Z coordinate. Vec 3 position. And then there is also attribute vec 3 for the color, red, green, blue. And then we need a varying variable for the color. And we also need, here we need a matrix. We need to define a matrix. Okay, I apologize because the voice. I apologize because of the noise. Yeah, my home is near the jalan raya, dekat jalan raya. Jadi many vehicles. Okay, we are going to continue. We define this vector three-dimensional for the X, Y, and Z position. And then vector three-dimension for the color, red, green, blue. And then varying variable for the vector color. and then we are going to define a matrix. Yeah. When I'm going to remind you about the Mr. Hazik presentation about his explanation how to move the position of our object in WebGL, we need to use a matrix. Yeah, if we are going to rotate or move the position of three-dimensional object or maybe two-dimensional object, we need to use a matrix of transformation, something like that. Here we are going to define the total. There are three matrices that we are going to use here. We are going to create a cube. The cube will has animation. Animation is rotation in the z coordinate, if I'm not wrong. Yeah. Oke, jadi kalau misalnya teman-teman ingat, kemarin minggu lalu Pak Hazik pernah menjelaskan terkait bagaimana cara memindahkan objek, ya kan? Kemarin itu ada kita bagaimana cara memindahkan objek dua dimensi seperti itu. Kita biasanya memanfaatkan yang namanya matriks, ya. Ada matriks di situ kalau teman-teman lihat. Jadi nanti ada perkalian matriks untuk mengupdate posisi-posisi dari masing-masing titik, masing-masing poin yang kita gambar. Kita lakukan perkalian matriks untuk mengupdate posisinya. Ketika posisinya itu diupdate, maka gambarnya akan bergerak. Ada animasi seolah-olah dia bergerak semacam itu. Nah, maka dari itu di sini di bagian Vertex Shader source, we are going to define a matrix, full dimensional matrix here. We can use a uniform variable, yeah, to define the matrix. In the previous week, in the 3 hour, jadi di beberapa minggu yang lalu, ya, di minggu-minggu sebelumnya, we need to define two-dimensional vector here to update the position of the x and y of our two-dimensional object. Jadi kita di sini butuh mendefinisikan vektor dua dimensi untuk mengupdate posisi dari objek dua dimensi yang kita gambar, ya. We need to define two-dimensional vector to update the position of object that we are going to draw in the canvas, ya. So here we define vector two dimension, but now we are going to change this. We are going to change this by using a matrix for dimension. Matrix for dimension. We will use the same variable. We will use the uniform variable. Kita tetap menggunakan variable uniform, but the data type of this uniform variable is different. Tapi tipe data dari variable uniform ini berbeda. We are going to use mat4. Matrix 4 dimensi. Kalau teman-teman masih ingat di slide presentasinya Pak Hazik. Saya sudah lupa, Bu. Nah, itu. Nanti bisa dibuka lagi, ya. Okay. For the first, we are going to define the position matrix. This will store the current position of the object. P matrix. We name it as P matrix. Kita beri nama sebagai P matrix. And then we are going to define another matrix. We call it V matrix. We are going to rotate our object, yeah, there. So we need to not position matrix, but this is a projection matrix. I apologize, guys. After I scroll the source that I had been read yesterday, I found that the P matrix mean projection matrix. Jadi setelah saya scroll artikel yang saya baca kemarin, saya menemukan bahwa P matrix di sini adalah projection matrix, bukan yang seperti tadi. Jadi saya ralat, ya. I apologize. This P matrix is used to store the matrix projection. This is for the projection matrix. And then the next, we are going to define a few matrix. Jadi kalau teman-teman lihat kemarin kan ada proyeksi gitu ya, ada projection matrix. We need to define another matrix here by using the matrix full dimension name. We are going to name it as V matrix. V matrix. V matrix. We call it as view matrix. Yeah. And then the last matrix here is M matrix. M matrix means for the movement. Yeah. M matrix here for movement. This M matrix.
M is for model.
Oh.
MODEL.
Model. Oh, wait a minute. I'm going to search. Model, not movement, sir.
According to our slide presentation, we need to define model matrix, view matrix, and projection matrix.
Yeah. Okay, yeah, that's right, Mr. Hazik. Yeah, I apologize again, guys. So many texts in my laptops. Yeah, the name is model matrix. Yeah, model matrix. There are three matrix: projection matrix, view matrix, and the last is model matrix, M matrix. Here we have already three matrix that we are going to use to create a three-dimensional cube and animate it. Yeah, we are going to animate it, membuat animasi dari itu. Okay, then point main, GL point size. I think this one will give will have no effect. Ya, ini tidak akan berdampak apa-apa. Ini I think because we are going to draw triangles, so the point size will be ignored. Ya, karena kita menggambar triangle dengan menggunakan GL triangle by using the GL triangle function, the GL size, GL point size will be ignored because it is define the size of the point. Because we are going to draw a triangle, so the GL point size will be ignored here. Okay, I'm going to delete it. And then GL position here. We are going to do matrix multiplication. I don't have Mr. Hajik's slide. Wait a minute. I'm going to download it first. I apologize, guys, because I changed the computer because of this electricity, because of the power. I changed my laptop, so I don't have the slide presentation of Mr. Hazik, so I cannot show you. Okay, wait a minute. I'm going to download it first. Wait. I'm going to log in to my SSO account. Okay. In Grafkom E. Okay. Till okay, I have the slide right now. I'm going to continue the explanation. Okay. This yeah. This is it, the translation matrix. Wait a minute, rotation. Okay, this is for the rotation matrix. Oh, not this one. I think this one. This is the coordinate system. Yeah, if we are going to change the coordinate in matrix, we need to use matrix. This is the three-dimensional matrix, I mean. We're going to change a frame in a matrix working with the representation of fine transformation. Yeah, we are going to transform our object. Wait a minute. Word frame, camera frame. This one, CTM. Yeah. CTM operation, model view, and projection. Yeah. We need a matrix, model view matrix and projection matrix to convert our vertex into in the virtual world into a camera coordinate, something like that. This is the projection, types of projection. So we need the matrix projection and then projection attributes. Okay, wait a minute. Yeah, something like that. We need a total 3 matrix here. Yeah, if you read from this presentation, yeah, if you remember, we need a projection untuk mendefinisikan proyeksi sudut pandang. Lalu juga kita butuh yang namanya model matrix and then sama view matrix di sini. Untuk ini. Ya, oke, kita lanjut saja ya. Ini PPT-nya sudah saya download. Nanti saya akan tunjukkan lagi beberapa hal yang sudah dijelaskan dari PPT. In this JL position, we are going to use the matrix multiplication, P matrix, V matrix, vector 4 position. Jadi sebelumnya kan seperti ini ya. We are going to change this A position. We are going to change this A position. Oh no, not the A position and the U change. We are not going to plus the A position with the U change, but we are going to multiply this vector 4 dimension with matrix 4 dimension, P matrix, V matrix, and M matrix. So for the new definition of JL position here in this void main function, we are going to multiply the P matrix, and then the V matrix, and the M matrix with the vector position. Vector 4 position. I'm going to delete this third variable in this vector 4 position because A position has 3 parameter right now. Because karena sebelumnya A position ini ada Karena sebelumnya A position ini menyimpan X dan Y, lalu sekarang A position sudah punya 3 variabel di dalamnya, X, Y, dan Z, maka parameter yang ketiga ini akan saya hapus karena dia mendefinisikan Z ya kan? Ya. Because in this case we are going to draw a 3-dimensional object, we need to define a position here, a position by using a vector 3 dimension. Because we use the vector 3 dimension, so this third parameter in vec 4 we are going to delete it because the A position itself has 3 numbers, has 3 parameters. So the third parameter in this code before need to be deleted. Okay. Jadi karena A position di sini sudah punya 3 variabel di dalamnya, yaitu X, Y, dan Z, maka parameter ketiga yang ada di vec 4 dimensi ini harus kita hapus, ya kan? Karena kan sudah 3 ya, X, Y, Z. Karena sebelumnya itu kan 2 dimensi, Z-nya tetap. Nah, karena Z-nya juga berubah, maka kita hapus yang di sini. 1 ini maksudnya projection. Okay. And then V color as a color. Okay. Kita sudah mendefinisikan, wait a minute, V color. We forget to, sudah. Saya pikir saya lupa. I think we forget to define the V color. Okay. After this, we are going to the fragment shader code. Yeah, fragment shader source, I mean. We are going to define the fragment shader for our 3-dimensional object. In this fragment shader source, we need to define the varying vector v color, GL vect color, v color. Okay, there is nothing. I think there is no change. Yeah, we do not we are not going to change anything in this fragment shader source. Yeah, we are not going to change anything in this fragment shader source because it's still the same. Yeah, kalau kita lihat di sini masih sama. And then we are going to create the shader for the vertex shader and the fragment shader. Yeah, vertex shader, vertex shader, vertex shader, vertex shader source, fragment shader source, and then we are going to compile the shader, and then here we are going to prepare the .exe file, yeah, to be compiled in the CPU. Create program. After that, we are going to attach to put the definition of each shader into one package here, vertex shader, fragment shader, and then we are going to link the program and then use the program. Okay, use the program. Okay, shader program. And then we have a variable. We are going to associating the attributes to vertex shader here. Before we start to use the program, we are going to attribute location, yet uniform location. Yeah, to change, but it's okay, I think. Okay, we are going to try this one, and then this for a position GL get uniform location. Wait a minute. Okay, get uniform location is here. Link program. Okay. In the article that I read, we put this use program in the end of this enable vertex attribute array. So I'm going to, because we need to define this first before we start using the paint and brush to draw. We need to define this. So link program, after link program, we are going to, not the position. Yeah, we are going, yeah. Before we update the position here by using the vertex a position before, we need to define the P matrix, projection matrix, GL, get uniform location, shader program, P matrix. This is the P matrix that we define in this vertex shader source, P matrix. And then after P matrix, there is phi matrix, and then M matrix. P and M matrix. Okay, then GL bind buffer array for the position GL. Okay, right now we are going to draw the vertex based on the position that we are defined. So we are going to use the linked list bind buffer GL array buffer here. Then vertex buffer. Yeah, we have defined the vertex buffer to store the vertex data here in the linked list, and then we define the position GL get attribute location, shader program, and then a position. Okay, a position. We name it here a position, a position. Okay, and then GL vertex attribute pointer position. Like what we ini harusnya nggak usah lagi nggak usah kita definisikan karena di bawah sudah nih. Oke, nggak usah ya. Sorry, saya tidak melihat yang di sini. Vertex attribute array ini ya. Okay, wait a minute. Because here we use a buffer to store the vertex data, we need to call this bind buffer. Jadi karena kita di sini menggunakan ini ya. Tadi vertexnya kan kita kan buat 3 buffer ya di atas tadi. We define 3 buffer. For the first buffer is used to store the vertex data. Jadi namanya vertex buffer. Vertex buffer is used to store the vertex data. And then the second buffer here is color buffer that is used to store the color data. And the last buffer is index data, index buffer. Index buffer. This index buffer is used to store the index data. So here, to draw the vertex, to draw the point, each point of the cube, we need to call the vertex buffer, because vertex buffer store the position of each vertex, karena vertex buffer menyimpan posisi dari vertex yang sudah kita definisikan tadi, titik-titiknya tadi poin-poinnya tadi. Okay, we are going to define vertex. Here I'm going to put it here. GL bind buffer, array buffer, vertex buffer. After this, GL position, GL position, a position, GL position, and then vertex attribute pointer position. Here we use 2 because we only use X and Y coordinate. In here, the size of our array is 2. Di dalam kasus ini, di sebelumnya, we are going to draw 2-dimensional objects. So, the size of the parameter that we are going to use in this vertex attribute pointer here is 2. Jadi karena kemarin kita mau menggambar-gambar 2 dimensi, maka dari itu parameter vertex attribute pointer di sini size-nya, ukurannya di sini adalah 2. Padahal di sini sekarang untuk studi kasus kita yang sekarang, for today cases, we are going to use we are going to draw 3-dimensional object karena kita akan menggambar objek 3 dimensi. So we need 3 numbers. We need 3. Kita butuh 3 bilangan to define the X, Y, and Z position. Untuk mendefinisikan posisi X, Y, dan Z. Seperti itu. Sini 3. Ini 3. Wait a minute. Position 3. GL float false. In the previous week, we defined the size of each element in the array is 5. Jadi di pertemuan sebelumnya kita mendefinisikan size per baris dari array-nya itu kemarin kan ada XY sama color ya. Jadi ini ada step-nya. Intinya ini step per elemen. Jadi kemarin kan kita mendefinisikan array. Kalau teman-teman ingat ada baris ya. Yang kemarin itu kan kita definisi array ya. Pertama ada posisi XY, lalu yang ke-3, 4, 5 itu mendefinisikan warna red, green, blue. Makanya ada 5 number yang kita simpan di situ. Nah, ini langkahnya 5. Indeksnya. Nah, itu. Di sini kita isi 0. Ya. Karena kan kita di sini sudah ini ya. Kita mulai indeksnya dari yang pertama. 00 seperti kok color ini ya. Nih. Seperti itu. Kita tulis 0. Wait a minute. 0 GL float false 0 for a position. Then for the color, GL vertex attribute array a position. Okay, that's great. And then for the color, we will use this bind buffer, but we are going to change this vertex buffer as color buffer ya. Setelah kita menyimpan, setelah kita meload satu persatu vertex buffer, posisi vertex, definisi vertex yang tersimpan di dalam vertex buffer, the next is we are going to store and load the color definition, definisi warna yang tersimpan di dalam color buffer. Ini kita sudah pakai bind buffer. Ini. Nah, di sini 0. Kenapa 0? Kalau kemarin kan kita pakai langkah ya, berapa step jaraknya. Jadi 2 yang pertama dipakai untuk posisi, 3 yang terakhir dipakai untuk warna. Makanya kita perlu mendefinisikan 5 gitu ya. Tapi kalau di sini yang color sama vertex, kenapa diisi 0? Karena kita menggunakan array yang berbeda, a different array. Ya, karena array-nya berbeda antara color and vertex. We define a different array to store the definition of the vertex, the position of the vertex, and the definition of the color. We use 2 different array. Yeah, so we set this one as 0. Okay, bind buffer, a color, GL get attribute shader program, a color. The name is a color. Wait a minute. Yes, that's right. GL vertex attribute pointer color 3 ya. Ya, size-nya ada 3. Color warnanya kan tadi 3 ya. Size-nya red, green, blue. And then we still use the GL float variable here, false. In this one we are going to change to 0. Nah, kalau pertemuan minggu lalu kita kan pakai, ya kalau saya punya nggak ya source code-nya, karena ini laptop. Ya, I change my laptop, so I don't have our previous meeting slide and etc. source code also. So I can show you the source code. Ya, kalau di pertemuan sebelumnya kita mendefinisikan kalau nggak salah ada 5 ya, 5 elemen, 5 baris dari array-nya. Baris pertama itu mendefinisikan titik pertama, baris kedua, titik kedua sampai ada 6 atau 4 tergantung dari fungsi primitif yang kita gunakan. Nah, 2 elemen yang pertama, 2 angka yang pertama digunakan untuk mendefinisikan X dan Y. Sedangkan 3 angka yang terakhir digunakan untuk mendefinisikan warna ya. The first 2 numbers in our array will be used to define the position of our 2-dimensional object. And the last 3 numbers in our array will be used to define the color ya. Karena itu, maka dari itu di sini kita, kalau di sini startnya adalah 0 karena dimulai dari indeks ke 0, 0, 1. Sedangkan untuk color karena ada 5, 0, 1, 2. Color dimulai dari warna kedua dengan size ukuran 3. Seperti itu ya. Wait a minute. Ya. False 0, 0. Here we set it as 0 because we need a different array variable. Jadi karena di sini kita menggunakan array variable yang berbeda, jadi kita tidak perlu mendefinisikan langkahnya berapa banyak stepnya seperti kemarin. Oke, GL enable vertex attribute array a color and then use program shader program. Oke. This one will be used to the user interaction ya, to interact with the 2-dimensional object that we draw in the canvas. We use a variable to check whether the keyboard or mouse is clicked or pressed by the user here. Now we are going to, before we use this function, we are going to to use the matrix for the movement process, for the drawing process and rotation process. Yeah, here we use the matrix that we are defined before. This is the matrix. First, we are going to make a function called get projection. This get projection will have 4 parameters that consist of angle, A, Z min, and Z max. Ya, jadi kita pertama akan membuat fungsi namanya get projection. Dalam fungsi get projection ini dia punya 4 parameter sebagai input, yaitu angle. Kalau teman-teman lihat untuk matrix projection, tadi saya sempat lihat itu ada angle sudut ya. Nah ini ya teman-teman, jadi untuk melakukan rotasi, jadi ceritanya saya ini mau merotasi objek 3 dimensi yang saya buat. Karena kenapa saya rotasi? Kalau tidak saya rotasi, objeknya itu akan kelihatan seperti 1 dimensi. If we are not rotate our object, we will not know that we have done with drawing 3-dimensional object. Jadi kalau kita nggak melakukan rotasi, kita nggak tahu kalau kita sudah menggambar objek 3 dimensi, ya kan? Gitu. Jadi kelihatannya kotak aja seperti itu. Padahal sebenarnya dia itu 3 dimensi. It is because of the point of view. Itu karena sudut pandangnya tadi, karena proyeksinya tadi. So, I'm going to do the rotation. I'm going to rotate my 3-dimensional object here by using the rotation matrix. We need angle here. Angle di sini kan theta ya. Nah, kalau di variabel saya kita definisikan dengan nama angle ya, sudut gitu ya. Ini kan sudut ya, cosine dan sebagainya ini. Lalu kita akan memutar, we are going to rotate the object in the z coordinate. Jadi kita akan menggambar objeknya, membuat objeknya berputar di sumbu z. Ya, seperti itu. So we are before we try to type the source code to rotate the 3-dimensional object, we are going to create a function to get the projection. Ya, jadi kita akan membuat fungsi untuk mendapatkan projectionnya itu tadi kayak sudut pandang dan lain sebagainya. Get projection. Angle A, Z min, Z max. And then there is a variable angle, yeah. We're going to use math function here. Okay, in the rotation process, we are going to use cos and sin, but in this get projection, we are going to use tan angle, tan, and math p. Wait a minute. Math angle kali math dot p. This is the degree. Then we are going to return as an array. Jadi nilai kembalian dari fungsi ini berupa array. The variable return in this function is an array. This array consists of what is that? Matrix ya. Array-nya ya mirip dengan matrix gitu yang berisi something like this. I need to show you. Sebentar, saya lupa dulu pernah ada projection di translation. Jadi kan ceritanya kita mau melakukan proyeksi ya teman-teman. Nah di proyeksi sini, sebentar. Oh sorry. Matan Injil kali 0,5 mati 180. Oke. Oke, nah di sini 0, 0, 0, habis 0, 0, and wait a minute. This is not okay. We're not going to use this one. This Z max X, Z max, Z min. Z max min, Z min. Okay, the last is minus 2 dikali Z max dikali Z min. Okay, this one is the same. The last is the same. Okay, this is the get projection function, and then we are going to define a variable called projection matrix. Yeah, this is the projection matrix. Yeah, the projection matrix, and then we are going to define a variable called projection matrix get projection putih canvas width canvas height then 1 and 100. Wait a minute. Okay. Then we need to define a variable for move matrix. For model matrix, like what Mr. Hadik say. Matrix. Yeah, this one. 1, 0, 0, 0. 0, 1, 0, 0. Sorry. Then this one is 0, 0, 1, 0. And the last is 1. Something like this. And then the view matrix, the last matrix is the view matrix. Sorry. This one is for view matrix. Yeah, it's still the same. Ya, masih sama ya, 1, 0, 0 seperti ini. Ini untuk view matrix, untuk perkalian matrix, di mana nanti masing-masing projection matrix, model matrix, and view matrix will be updated based on the here. Not updated, will be used in the multiplication process to update the position of the three-dimensional object that we draw in the canvas. Jadi matriks ini akan kita gunakan untuk mengupdate untuk perkalian matriks ya, untuk perkalian matriks untuk mengupdate posisi dari objek 3 dimensi yang akan kita gambar. Kok caps lock. Okay. The next is We are going to do the some translation here. We are going to do we are going to translate not translate. Kita akan melakukan view matrix ya untuk melakukan sebentar translating the z coordinate here. We are going to translate the z coordinate view matrix to zoom. Wait a minute, I'm going to sorry, to show you the code. The battery saver mode. Okay, I hope. Yeah, okay. I'm going to do it fast. So before the battery is before my computer turn off, I hope I can finish this material for you. View matrix. 14. View matrix. 14. 6. Something like this. And then to rotate, we need a function for the rotation process. Here, function rotate, yeah, M and angel. In this rotation process, we need to use sin and cos like this, yeah. For the 2D rotation, we need x bar and y bar. In this x bar and y bar, we need to multiply the r with the cos theta, and then for y bar, we need to multiply the r with the sin. Yeah. For the three-dimensional object, we need to create a matrix. So we are going to do multiplication. We'll multiply the matrix to make the object rotate. Rotate based on z, yeah. Rotate z coordinate. For C, we are the math. We are going to cos angel, yeah. Here we are going to use the cosine, cos theta, sin theta. First, we need to see. We'll store the result of cosine. Yes, variabel C digunakan untuk menyimpan hasil cosine dari angelnya itu tadi, cos. Lalu kita ada var S, math, sin dari angelnya. Lalu ada var mv0, di mana ini ada var ini ada wait a minute, math. Oke, mv0 ada m0, mv4, m4, lalu mv8, m8. This m0 here sama dengan C, hasil cosnya tadi ya. C dikali M0 dikurangi S dikali M. Ini kita melakukan perkalian matriks ya. Karena di source code ini kita tidak bisa mengalikan matriksnya, jadi kita kalikan satu-satu. Untuk M0 kita kalikan ini, cosnya dikalikan M0 dikurangi S dikalikan M1. Untuk M4, di sini kita akan C kalikan M4. Sorry. We're going to minus by S multiply by M5. This one. And then for the 8, C multiply by M 8 minus S multiply by M 9. This one, and then for the M 1 still the same, C dikalikan M 1 ditambah S dikalikan MV 0. And then we are going to update for the 5th and 9 index. Sorry. Okay, this one. Okay, I forget. Okay. And 4. Okay. 4 and 8. Okay. Then next we are going to rotate in the for the rotation in X and Y. We will use the same, yeah, like this for Z, and then for X, and then this one is for the Y. Mascos Angel M. Okay, this M is an array. For C, M is the parameter here, input parameter here. Math cost in Angel, yes, MV, yeah. This is for the M1, 5, and then 9. I don't know why. For MV1, M1, MV5, M5, MV9, M9, and then this one, we're going to change it 1, 5, dan 9. 1, 5, dan 9. Lalu di sini juga sama. MC kurangi M 2, 6, 10. S, ya. S 2, 6, 10. For the 159, 2, 6, 10. Still the same. 2, 6, 10. And here MV1, MV5. This one is MV9. MV1, MV5, 9. Okay. M2, 6, 10 dikalikan C. We are going to multiply the C, the result of the cosine with the angel. And then we are going to plus, we are going to add this MV1 multiply by S, MV5. Yeah, okay. That's right. And then the rotate Y for the Y axis. Math cos, sin cos, MV0, M0, M8, M0, C. Dua, 6. Okay, if all of you confused about this matrix multiplication, I'm going to explain to all of you about the detail about what is the meaning of each line on this source code. But not today, maybe last week, or maybe I'm going to share for you the URL, maybe a slide so you can read it, so you can understand about the meaning of this code. Yeah, because I have a limited time because of the power battery of my laptop. Okay. Here 2, 6, 10. Okay. Okay. I think this is different. Yes. Thus, and this one we are going to change it. Sorry. Okay, I apologize to all of you because of the limited of time that I have because my battery power is limited. Okay. I'm going to give you more detailed explanation about the each line of the source code in the next week, or maybe I will provide you a PowerPoint so you can read it. Okay, the next step is drawing. I'm going to comment the user interaction here first. We are going to comment here. Before we are not going to use this for today, but maybe next week we are going to add this interaction, and we are going to explain about the 3JS. Yeah, maybe okay, a little sedikit materi tentang 3JS. Okay, this is the drawing process. Yeah, for the drawing process we need to define variable for time. Ya, for time. Ya, untuk waktunya ya, mungkin waktu begini. For the time, I'm going to set it as 0. And then, ya, seperti biasanya, kemarin kita mendefinisikan fungsi namanya render. But right now, yeah, we are going to define the same function. But we're going to define the function sama dengan, oke, sebenarnya sama aja sih. Wait a minute. Okay. We are going to define a function. The name of function is animate. Yeah. Store it here. We are define the dt, time, min waktu yang sebelumnya tadi. Lalu rotate z, move matrix here, dt dikalikan 0,05. This is for the time. Ini 0,05. Ini juga sama untuk yang rotate X, Y, dan Z. Kita akan melakukan rotasi. Oke, sebentar. Hasilnya kita lihat ya seperti apa. Sorry. Enter. We will define a different time. Ya, kita akan mendefinisikan kecepatan yang berbeda-beda mungkin. Mungkin ini bukan time ya, tapi lebih tepatnya untuk speed-nya, kecepatan yang berbeda-beda untuk masing-masing ininya. Rotasinya tadi, rotate X, Y, Z, time. Di sini sama dengan time. Time. Lalu kita akan GL enable. Nah, karena kita menggambar objek 3 dimensi, because we are going to draw 3-dimensional object, we need to enable the depth test. Kalau nggak salah di slide awal kita pernah belajar tentang depth, kedalaman. Jadi function depth in WebGL is used to differentiate between object that is put in front of other object. Gitu ya. Fungsi GL depth ini digunakan untuk membedakan objek-objek yang diletakkan di depannya objek gitu ya. Jadi kalau ada objek yang banyak, if there are many object in our environment, the object that is put in the front yang paling depan di depan will be show in the camera, will be captured by the camera. Jadi objek-objek yang ada di depan akan di capture oleh kamera, and then the object yang ada di belakang, objek yang terletak di belakang itu akan ketutupan gitu ya oleh objek yang ada di depannya. So to enable the depth test, we need to GL enable depth. Okay, like this, if I'm not wrong, depth test. GL enable depth test, yeah. And then this one, depth function. GL equal. So these two lines is used to enable the depth test to make sure the object capture in the camera, ya, based on the position. Jadi ini dua baris kode ini digunakan untuk untuk meyakinkan untuk menjamin untuk melakukan pengecekan ya, to check objek-objek yang ada yang harus di capture oleh kamera yang akan muncul di layar kamera itu apa saja. Jadi kalau misalnya ada objek di depannya ini jadi yang ketutupan yang mana, nah semacam itu kita pakai yang namanya depth test. Kalau nggak salah dulu di PPT ada, kalau nggak salah PPT yang pertama atau yang pertemuan kedua saya lupa. Nah itu, you can open the PPT and read more about this depth test in that PowerPoint. Okay, clear color like the usual we use clear color. We are going to kita akan memberikan warna abu-abu ya untuk ininya background kita. Nah, alpanya saya isi 1. And then GL clear depth. Nah, ini kita kalau misalnya kita pakai depth test, kita juga perlu menggunakan fungsi clear depth. Ini kita isi 1. Minggu depan akan saya jelaskan satu-satu mengenai ini. Lalu kita menggunakan yang ada di sini kayaknya. Oh enggak. Clear depth. Wait a minute. Oke, seperti biasa ini untuk viewport-nya. X-nya kita akan pakai titik pusat origin. Width ini adalah pakai kanvas sesuai dengan panjang dan lebar kanvasnya. GL clear ya, seperti biasa. GL color buffer bit. Nih untuk meng-clear ininya, background-nya. Nah, karena kita menggunakan depth, GL depth buffer bit. Nih. Nah, di sini kita akan melakukan transformasi matriksnya tadi untuk GL uniform, matrix karena 4 dimensi ya. Ini lokasinya adalah P matrix. Ini kita isi false. Lalu ini adalah berdasarkan projection matriksnya tadi. Nah, seperti ini. Ini untuk P. Ini projection. Nanti kita juga akan buat untuk yang view dan model. Uniform, wait a minute, P, and then M, false. Nah, this one for the view, and the last is for mo, matrix. And then GL, bind buffer, GL, element, array buffer, index buffer. For the mesh, we are going to draw the mesh. Tadi kan kita sudah gambar titik, gambar warna, nambahkan warna. Sekarang kita akan nambahkan mesh dengan menggunakan GL bind buffer. Tadi kita sudah definisikan index buffer here. And then GL draw elements. Draw elements. Nah, ini primitifnya, fungsi primitif yang akan kita gunakan adalah GL triangle. GL triangles, lalu di sini count-nya ini berdasarkan indeksnya tadi, index dot length ya, panjang indeksnya tadi. Lalu ada GL unsigned sort for the type, unsigned sort, and then offset we are going to start with 0. Triangles index length GL unsigned sort 0, and then window dot request. Okay, wait a minute. I think it's okay if we are going to use window. We can use request animation frame like this. Animate. Sorry, why? Karena tadi ini ya animation frame, animate. Okay, yeah. Something like this. Okay, we are going to call this animate function. We are going to set the time as 0 to start the 3D dimension object. Okay, we are going to check. Okay, the background has changed as abu-abu, as gray. We are going to inspect the element first. Wow, there are 257 warning. We are going to check it first. Too many errors. Wait a minute, console enum is not... Okay, wait a minute. Kita cek dulu. Window request animation frame, animate, GL unsigned sort. Okay. Okay, draw elements, triangles, index length, GL unsigned sort, 0, bind buffer, GL elements, array index buffer, uniform matrix, full, matrix, move matrix, matrix, GL color bit, buffer bit, viewport, 0, canvas width, clear depth, clear color. Okay, depth function for the waktu sama dengan time. Then rotate.
Excuse me, Bu
Yeah,
Siska.
yeah.
Maybe unsigned short itu kayaknya typo.
Oh yeah, I apologize. Okay, unsigned sort. Wait a minute. Still, there's no error. Yeah, but the object is not view here. The object cannot be shown. Content type header. There is no error, but the object cannot be shown in this. Okay, thank you very much for the correction. Okay, correct my code. Wait a minute, I'm going to check it. Cool. Depth function. Okay. This is for the rotate Z, X, and Y. Waktunya 0. Then we are going to time. Okay. Move. DT 0,005, DT 0,0. Matrix rotates. Okay. Then this is for the rotation function. M and angel, math cos angel, sin angel, MV0, M0, MV4, M4, 8, and then C 048, S 2610 C minus, we're going to minus S multiply by MV0, MV4, MV8, and then this is for the rotate X, MV1, MV5, MV9, 1, okay, C multiply by M1, M5, MM9, minus S multiplied by M2, M6, M10. Then this one, C multiplied by M2, M6, M10. Okay, we're going to end plus with S multiplied by MV1, MV5, MV9. Okay, it's okay. And then for the rotate Z, M angel, math cos sin angel, MV 0, MV4, MV8, M0, J0, SM, SM, M8, wait a minute, M159, J ditambah S. Okay, this is for the view matrix. View matrix. This is the view matrix. 1, 1, 1. Full dimensional. Okay. Get projection for the projection matrix. 40 canvas width, canvas height. Oh, this is one client height. Not client height, but canvas height. Okay, maybe because of the position, I don't know. Let's see. No, there is no view. Canvas width, canvas height, 1. I'm so sorry. Ya, saya kurang teliti kadang. Function get projection, angel A. Okay, this A variable become gray. I don't know. Wait a minute. Z min, Z max. Ang matan angel ni math P return. Oh, this one. There is A here. 0,5 dikalikan A. Yeah, because if we define the matrix wrong, I think the position will be also wrong. So the object will not be appear in the canvas because of the position, the wrong position. Wait a minute. Minus Z max. Jadi kalau kita definisikan posisinya salah, salah rumusnya, objeknya tidak akan muncul di layar. Kenapa? Karena posisinya nggak ada gitu ya, nggak di situ gitu. Z max, Z min. So we need to be careful to check our code. Ya, jadi kita harus hati-hati mengecek kodenya. Dikali Z max, Z min. Okay, that's right. Z max, Z min. Okay, then. Okay. I think I made a mistake again here because of the position. 0, 0 means Z max plus Z min dibagi Z max min Z min minus 1 0, 0, 2 kali Z max Z min dia bagi Z max kurangi Z min. Math tan angel math P bagi 180. Okay. I don't know. Okay, this one. This is our cube, guys. Finally, I forget. Yeah, jadi my mistake is here. Yeah, in the get projection. So the position of the object is not in the canvas. Yeah, so it cannot be shown in our canvas. Oh, sorry. This one. This is our object. I think I'm going to change the color here, the yellow color. Yeah, warna yellownya tadi ketumpuk ya. Kalau saya akan ganti warna yellownya ya, jadi warna yang berbeda. We are going to change the yellow color. Hey, wait a minute. The green and blue. Yeah, can you see that? I'm going to check it first. The color definition. Okay, next week I'm going to complete this source code. with the explanation of each line ya. Next week saya akan coba menjelaskan sedikit saja waktu mungkin 15 menit tentang maksud dari masing-masing kode yang ada di di source code ini ya. I'm afraid my battery is not enough to continue the explanation because look at here. It's 9% remaining. I'm afraid my laptop will turn off automatically because of the power. Okay, wait a minute. I'm going to change the color. Yeah. Is there any wrong definition here? So the color.
There is something to need to be fixed about your indices.
Yes.
You in your second line of your indices, it's
Yes.
written 8, 9, 20. It should be 8, 9, 10.
Okay. So the mesh color caused this yellow color, something like okay, yeah. Jadi because of that mesh, so it draw this. Yeah. Thank you very much. I apologize. Okay. Ya, jadi tadi yang salah adalah gambar mesh-nya ya. Jadi harusnya di sini adalah 10. Karena kalau 20 di sini kita nanti masuknya ke warna yellow yang ada di sini. Di colors yellow dari titik yang sudah kita definisikan. Tadi kan kita we know untuk apa sih variable index gitu ya. Index variable di WebGL ini untuk apa gitu. Jadi index variable itu adalah numerical value. Jadi semacam angka, nilai angka. This one is used to identify the vertex. Ya, untuk mengidentifikasi vertexnya itu tadi. This numerical values will be used to identify the vertex and also will be used to draw a mesh in WebGL. Ya, jadi digunakan untuk menggambar mesh juga. If we type a wrong number here, so the vertex definition, ya, jadi gambar vertexnya juga akan berubah. Tadi kan kita lihat ada warna biru dan hijau yang jadi satu kotak, satu rectangle, become one rectangle. Jadi dia tersusun dari dua segitiga, satu segitiga warna biru dan satu segitiga warna hijau kalau nggak salah. Nah itu karena tadi ini, karena posisi ini. Ini ya 20. 20 kan harusnya di sini. Kuning ya, untuk yellow. Sebentar. Ya ini yellow ya, untuk sisi-sisi yang F. Nah yellow ini. Makanya tadi dia masuk ke situ. Harusnya di sini bukan yellow tapi 10. 10 ini berarti mungkin tadi adalah biru atau hijau yang ada di sini. Seperti itu. 23. Ini 23 maksudnya 23 kan harusnya kan tadi 24 ya harusnya. Karena kan indeksnya dimulai dari 0, 0123, 023 dan seterusnya seperti ini. Ya, oke. Mungkin ada yang mau ditanyakan dulu. Is there any question or maybe Mr. Hazik want to give more detailed explanation about this code, or I'm going to complete this source code maybe next week. I'm going to explain this source code, the meaning of each line, yeah, especially in this line, yeah. Maybe some of you doesn't understand what this mean, ya. Ini intinya perkalian matriks, tapi kita mengalikannya ya satu-satu. Nah gitu ya. Jadi kita nggak bisa kayak MATLAB. If we use MATLAB, we can do the matrix multiplication. But if we use JavaScript, we need to multiply each number in the matrix one by one. Makanya di sini kita mengakses posisi dari matriksnya itu tadi. Seperti itu ya. Perkalian matriks. Jadi kita mengkalikannya satu-satu seperti ini. Ini. Nah ini nanti saya akan coba implementasi dengan yang ini juga. Okay. Is there any question guys for today's meeting?
And then let's turn to my screen book.
Okay, Mr. Haziki.
So you can take a break.
Okay.
You
yeah.
You don't need to.
Yeah. Okay.
So after we heard the explanation from Bu Siska, give me one moment, chatting should be here. All right. So Bu Siska has taught us about kind of a quite tedious approach, prone to error approach. But the good thing is what Bu Siska has told us is the closest one to the theory that we have learned in the previous meeting. So we need to define the matrix definition, etc., manually inside the JavaScript application. Here, I would like to show you. I think it's more efficient way and more effective, I believe, by using what's so called a GL matrix. Okay, so and this is my approach. I tried to follow Bu Siska's tutorial as well, but the only difference I think here I didn't separate the position and the color, so I just leave it as it is inside the vertices array. So I do not have a colors array, but it's okay. It's just a matter of uh, buffer difference. So it's gonna be different in here when we ask the pointer, the attribute pointer, get or obtain the values from the vertex from the array buffer. But the rest of the things is the same. Also use the indices, the similar indices. Or maybe if you want, you can also access my code and copy and paste as necessary. Or you can create a different branch for today's lesson, so you can save or store your work, your current work that is uh, based on the Busiska's work, and then you can also redesign your JS application according to my example. There is some difference, so that you can learn some benefits from it. So let me put the VS Code environment live share, and here you may join my VS Code environment. I will check it there if you want to copy and paste. It works the same. It's just similar to what Siska have done. So this is the cube. Uh, and I also rotate the cube accordingly, and it bounced back uh, against the frame, so to make sure that it is not out of the frame. And here we go, the explanation. Let me go back to the Visual Studio Code. The shaders are the same. It's just like what we Busiska have has defined, except for this one. So because I think if I use one, it's gonna be different. It's gonna be hard for me previously to track the changes, because if we use one, it means that the cube reaches our word frame, so it reaches the edge. So it's hard to track. But I think now it's okay because we have applied the perspective. So let me change back to original. So it's gonna be something like this. Is very huge, but I think it's still okay. We cannot see it clearly, its movement. So you can decide whether you want to divide by 2, or maybe you want to make it like a 2/3 is also okay. I'm sorry, should be in a float. Okay, for example, it's up to you. Just play with the number. And then the other important things that I need to mention is the use of GL matrix for defining the identity matrix. So for the 3 model, view, and projection matrix, I instantiated or initialized them using GL matrix mat for create method. Maybe you are now questioning or wondering where did I get this GL matrix? You can visit its website, or basically just need to open your browser and open your Google search engine and type GL matrix, and you will find the first result in the query would be the website to the GL matrix. And here you can download the zip file, and later you can extract the zip file and try to find the distribute folder. So if you extract the folder, you can get something like this. And the thing that you need to import to your, I'm so sorry, I just cut it. So it should be in here. So it's gl.matrix.min.js. So it's already inside my project. You can see it on my Explorer. So it's inside on my project already. You can choose to use this or to use the GL and test matrix is okay. The only difference between those two files is the GL test matrix is more readable. So you can see clearly what are the methods and properties inside this library. But for the GL test matrix, min.js is the compressed version. It means that it's for optimization. So for more efficient use in our application, but it's unreadable. It's hard to track or to read the properties and the method inside. But it doesn't matter because later if we want to apply or use some methods from this library, we do not need to go into the file, but we need to go to its documentation. So you need to visit its website and click on this view the documentation. And most of the transformation matrix that we apply today, we are applying today is in mat4 module. So you can click in here. And for example, for instantiating or initialize the matrix, you can use the create. It's very easy. This is to create a new identity matrix. So all the function that is prefix that has GL matrix prefix is basically some method that we use from this GL matrix library. So please have a check on the documentation to understand better about how to use it. Here, uh, also use the GL matrix to define my perspective. So instead of defining the element of the projection matrix one by one, just like what we have seen from Busiska's code, we just need to define the critical elements or the important element from the perspective itself. I promised you to derive the formula how to get the perspective projection formula from the Al Alhazen uh, discovery one millennium ago, but maybe not today. Hopefully, I can make it next week. But the thing is that you need to know from to create a perspective matrix, you will need one the FOV. So this is gonna be the field of view. So how wide is your eyesight? So in here, I indicates that the angle of field of view in here is 60 degree. Why is 60 degree? Because math pi it is in radian. It is in radian, and math pi is 100. Math pi radian is 180 degree. If I divide it by 3, so I got 60 degree. You can play with the numbers if you want. And then the next one is I think the ratio between the width and the height of we call it the frustum of the perspective. I will explain about the frustum next week when I derive the formula. And then this is the near clip, and this is the far clip. you need to define the near clip and the far clip for the perspective projection. Let's take it for granted. Next week we will understand that in more uh, detail. And this is for the projection. And then for the view, I also use the method from the GL matrix. Here I use what's so-called look at. You can also check on the documentation. In this look at, you need to define first. Maybe I need to type in here. So this is the dimension, the screen, the ratio, screen ratio. And here I think it is the near clip. This is the far clip. And for this look at, you need to define the camera position. So I set the camera backward and translate it back across the Z axis. Z positive means it's out of the screen. So it goes into our eyes. So I set it back. So in order to check, in order to see the whole picture of our object, so I set it back about 3 units, and then this is uh, the point where camera looks at, and then this one is the up vector of the camera. Because sometimes if you want to take a picture, it's very possible that you want to take it like with some uh, angle, okay? So you want to make it more fancy, I don't know, because in Instagram there are a lot of, or when you do some videography, cinematography, you want to have that kind of approach. It's more artistic, etc. So you can change the up direction of the camera. But here I'm just gonna use the default, means that it's up. It points towards up direction, so it's a kind of the 1 unit y factor. All right, and both of these matrix value, we need to transfer them to the shaders, okay, using these GL API, WebGL API functions. All right, and then last but not least, the model is inside the rendering pipeline, the rendering loop. We need to initialize the matrix, and then here we go. If we want to apply some transformations, you can stack up your transformations into the model. What does it mean by staking up the transformation matrix? It's just like doing the post multiplication. So the post multiplication is the way we stack up or pile up the transformation for our objects. You can check on my previous week's slide the explanation about the CTM and also the post multiplication. So it's basically demonstrate those theory. So for example, here I would like to rotate my cube or the whole vertices about the x-axis. This is x-axis, and how much is the rotation? I'm just gonna use the value of chains, so it's the same value of the speed translation. It's okay. It works perfectly in this case, and it's in radian. Okay, so the angle in here is radian, and also I would like to rotate. So once the rotation is defined, and then we store so this model matrix, the initial model matrix, will be multiplied with or by this matrix, rotation matrix. So GL matrix will handle that for us, and then it will store the results to the same matrix. So it's updated. It's being updated here. And on the next line, when we want to rotate the whole things, the vertices about the y-axis, this model is actually the new value, the new model with the new value obtained from the previous rotation. So, and then we update again the rotation about the y-axis and store it to the same model matrix. And at last, we would like to also apply the translation in here and store it to the model. And this is the translation vector. So it changes over time, right? So it's always updated. So it's not going to be zero. This is just the initial vector. It will always change across the time as we have defined here. And I put some definition to make it like a bouncing back towards the wall, against the wall. Now, as the perspective and the view matrix, I also need to transfer the model matrix value as the uniform to the shaders. This depth test is necessary. Otherwise, uh, your application will not consider where is the vertex that is far away from our site or closer to our site. So this is a necessity. Is a compulsory to make it like a perfect 3D perspective as a result. And then we also need to clear the buffer bit every time and every frame. And these two things altogether representing the hidden surface removal that we have learned from, I think, 3 or 4 meetings back then. And then Bu Siska have told you about this, and here we go. As a result, we got this as what was that over here? Okay. Let's try it out to disable this. So if I disable this, you can see it here. So it's like there is no red. Oh no, there's no red. The red is kind of back there. So if we disable the GL depth test, basically the shader will execute the color according to this indices order. And sometimes the indices that come last is it should be are the indices that come last, it should be something that is behind uh, the cube. It should be something that we should not see it because it's blocked by the something closer to our eyes. But it doesn't apply such because we disable the depth test. So that's why it's very necessary for us to enable the depth test to ensure. So despite the order of the indices, we need to make sure that everything that's closer to our eyes should be drawn and block something that is located far away from farther from our eyes. So that's all. Hopefully, you got the idea. Now, maybe I will not give some chances to ask questions. I would like to continue first with 3GS uh, boilerplate. Just a quick. So now I would like to show you the how to work with the 3GS because this week you are required to find to find to find and form a team to later. I think starting from the week 9, we will start to invite you to explain about the 3JS, and we will invite. I think we can invite 2 teams, 1 or 2 teams. But for week number 9, maybe we can start with the 2 teams. So one team will have 1 hour to explain their topic, and then another team will have the rest 1 hour to explain yet another topic. And to prepare that or to look forward to that, so we need to understand a bit about how to use the 3JS. So please, now you may need to Google the 3JS. Okay, I believe that the first result on the query will redirect you to this website. So you need to spend more times to understand this project, this library. The first step, perhaps you can go to the GitHub. So I'm gonna open it in a new tab. I suggest you to simply visit the build directory in here, build directory, and then open the 3.min.js, and then click on the role button over here. And then you can Control A or Command A, and then Control C or Command C, and paste it to a new file in your project. So I'm gonna do it in here, and call it the same 3.min.js, something like this, and paste it here and save it. Okay, so I got the library already. Now I can move back to the 3JS website and try to check the documentation. And here we go. We can copy and paste the creating a scene. I think I can just directly go here. You can check the explanation, the detailed explanation here, but I'm just gonna skip it and copy this snippet, this code. And I would like to create a new HTML file called free.html. Give me a moment. Oh, it takes really some time. Oh, finally. Okay. And I will paste it here. And let's try to run it first. So I'm going to go to my browser and change this to free.html. Yeah, I'm sorry. I need to change this. So the script under the body should be free.min.js. And here we go. So this is the what's problem? Okay, anyway, at least it works. So here's if we want to draw a cube with using WebGL approach, you understand the pain, right? You need to define the whole vertices, and it's tedious work. In 3, they simplify because it's a library, so they simplify the approach to draw something by defining several properties and several methods to make you easier in drawing the similar or even the same WebGL application. So this application is also WebGL application. Okay. However, to draw this, we do not need to specify the vertices. We just need to call box geometry. That's it. So this is basically represent this work, starting from here up to the defining the definition of the vertex attribute pointer, the whole things to here. And then you may need to define the material. This is the difference. And we haven't yet applied this on our practice during our hands-on because we will start to use this after learning about the lighting and shading. I think it's gonna be in the 2 or 3 next week. Okay, it's something that is required for the lighting, but if we do not have a lighting, so I think that's okay for the WebGL if you do not have the material definition. And then the object that we would like to see as the results of our drawing is called mesh. In 3JS, it's called mesh. Mesh is a pair of geometry. Geometry is kind of just the collection of vertices data. And the material is how the looks, the appearance. So far, we defined the appearance as already, I think, but it's included in the same vertex buffer. In 3JS, they separate it and make it more tidy. It's more manageable. Okay, and then we add the mesh into the scene. So scene may consist of a lot of mesh. Okay, a lot of mesh. So you need to define the scene as a like the grandparent. So that's gonna be the root of everything, the whole objects inside our graphics application. And this scene will be combined together with camera, the definition of camera, and we will put it as parameters of this renderer function. So the scene will be part of these parameters of this renderer function. The camera define one of the use or the benefit of the camera is it will define the projection, the projection matrix, and I think also the view matrix. So you can define it here in the camera, and you can play with the many possible camera that you can use for this 3JS graphics application. You can of course have a check on the documentation for the detail. Okay, everything is here, so you can choose many cameras many cameras, and even the camera for the VR is also available in here if you want. And what else? And as for the render, is necessary for you to define as a WebGL renderer and then put it as the child of the DOM, document object model. And then you may need to use the request animation frame as always to define the render loop. The render loop in here is this animate, okay? And you need to call it at least once out of this function definition. And oh yeah, one more thing. This const is actually the way we use JavaScript using the ECMAScript standard 6. For our application, we just simply using var, but there are some differences using whether you want to use var, let, or const, and you may consider to use which one is suitable for your needs. But var is more the most flexible one, but is I think it's not good for our memory. Where you want to make sure that, for example, your scene will not uh, uh, modified within the codes. So just once you declare it, once you define it, you will just only use it without any without any purpose to without any objective to change its value. Then const is the best option. It's just like you define it just once and then you use it in the rest of your code in the rest of your codes. So that's why everything is here is the using const instead of var. You can learn about these three differences in the ECMAScript 6 standard. I will not cover that because I think it should be in the web programming course. And that's all. So let me push this to our GitHub. And you can have a check there. I believe that it should be here. So I put it in our class. So you can have my repository over here if you want to learn in more detail about what we have learned so far today. Okay, that's all. Do you have any question about all the things that Busiska taught you and or maybe what I have explained to you? Go ahead if you want, if you do have any questions. Otherwise, let me close the session. Or maybe Pusiska, are you still there?
Yes, Mr. Hazik. I have
Maybe we can
changed my.
close the session. You may close the session if you want.
Okay, wait.
Oh gosh, I didn't. Did I? Oh yeah, I changed.
Okay.
Yeah. So I
Okay.
think I can.
Thank you very much, Mr. Hazik, for the explanation. Is there any question, guys, for the today's session? Today we have learned about the how to draw three-dimensional object by using the WebGL. We try to define one by one the vertex, the point location, the color, etc., the mesh, and then after that, Mr. Hazik explained to simplify my work by using GL matrix. Yeah, you can use GL matrix to simplify my work. I define so many number in my array in my matrix, so you can simplify my source code by using Mr. Hazik's approach by using GL matrix. And then after that, Mr. Hazik explained about the 3GS. In 3GS, we can learn to draw the three-dimensional object easily because it is a library. So we do not need to define all the vertex or the position of the vertex like what we had done before in the previous source code. Yeah, we only need to download the library and then call the function of the in the library, something like that. We only need to learn the function in the library, how to create the cube, how to create the lightning, and etc. You can read the documentation that is provided by the 3ds. Okay, that's all for today. Thank you very much. If there is no question, I think I would like to end this session by praying together. Okay, let's pray together. Finish. Thank you very much for your attendance in this today's class meeting. Thank you very much, Mr. Hazik, for your help. I apologize because of the electricity, so I cannot explain the material clearly to all of you. I think next week I'm going to prepare the source code with the detailed explanation on it. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.